Question number 6. Consider the function f of x is equal to negative 1/4 secant 1/2 x minus pi over 3 plus 5. The first step we need to do is to find a, b, c, d. So a is equal to negative 1/4, b is equal to 1/2, c is equal to pi over 3, and d is equal to 5. We know that the amplitude of the associated reciprocal function is the absolute value of a, so that is equal to 1/4. And we're working with the associated reciprocal function. The associated reciprocal function for secant is cosine. So we're looking at the cosine function here, and the goal is to graph cosine function in order to be able to graph the secant. The period for this function, we know that the period is equal to 2 pi over b for the function cosine. So this is equal to 2 pi over 1/2, which is going to be equal to 4 pi. State the phase shift. The phase shift is c over b. So this is equal to pi over 3 divided by 1/2, which is going to turn to pi over 3 times 2 over 1, and that is 2 pi over 3. And then the vertical shift, we know that the vertical shift is d. So in this case, it's equal to 5. Now, before we start graphing, we will create the table of values. So I'm going to start with the original numbers. Here is x, and here is f of x or y. To find the values for x, I'm going to start with 0, and then I'm going to take 1/4 of the period. So period divided by 4 equals 4 pi divided by 4. So it's pi, and then I'm going to add that here. So pi, 2 pi, 3 pi, 4 pi. So I've just added multiples of 1/4 of the period. Each time I'm going to add that 1/4. So pi, 2 pi, 3 pi, 4 pi. Now, looking at the original cosine function, looks like this. The original cosine function, this is the amplitude here, and then 0, and then negative the amplitude, and then 0, and then the amplitude again. So the amplitude in this case, or a, I should say a, not the amplitude, is negative 1/4, 0, and then negative is positive, and then 0, and then negative 1/4. Now we have a vertical shift and we have a horizontal shift. So the horizontal shift gets added to the horizontal line, which is the x values. So the horizontal shift is 2 pi over 3, or that is the phase shift. And then the vertical shift gets added to the y values. Y is all of the vertical values, so that is plus 5, plus 5, plus 5, plus 5, plus 5. Now we're going to find the values here. So just create the table one more time. Now with the new values that after the addition of the shifts. So the first value is 2 pi over 3. The second value is 5 pi over 3. And then we have 6 plus 2 is 8 pi over 3. 9 plus 2, 11 pi over 3. And then 12 plus 2, 14 pi over 3. And then in this case, I have 5 minus 1/4 will give me 4 and 3/4. I'm just going to do it like that. 5 plus 0 is 5. 5 plus 1/4 is 5 and 1/4. And then 5 again, and then 4.75 again. Now the last phase is just to graph. The first step is to graph the vertical shift. The vertical shift is 5. So 1, 2, 3, 4, 5. I'm going to be approximate here, and my graph is probably not going to look pretty. So this is y equals 5 for the vertical shift. And now I'm going to plug these numbers. I noticed that all of these are multiples of pi over 3, so I'm going to put these at equal spaces, and then I'm going to increase by pi over 3. Pi over 3, 2 pi over 3, 3 pi over 3, and I'm not going to reduce that one, 4 pi over 3, 5 pi over 3, 6 pi over 3, 7 pi over 3, 8 pi over 3, 9 pi over 3, 10 pi over 3, 11 pi over 3, 12 pi over 3, 13 pi over 3, 14 pi over 3. Now, at the point 2 pi over 3, the function is equal to 4.75. So approximately here. Not exactly, but that is approximately the first point. The second point is at 5 pi over 3 and 5. 5 pi over 3 and 5 is here. And then 8 pi over 3 and 5 and a quarter, so approximately here. And then 11 pi over 3 and 0. And then the last one is 4 pi over 3 and 4 and 3/4, so approximately here. I'm going to sketch the graph of this function, which is basically the reciprocal function in our case, so we don't care about that one. And then I am going to create the asymptotes for the function. So here is the first asymptote. It happens at the 0, or the point where the reciprocal function meets the midline, the vertical shift. And then here again. Of course, these are approximate. And then the function that I'm looking for is the secant function. So for each of these bumps, I'm going to put a parabola like this. Here is a bump, here is a reverse parabola. And I can finish that, but I'm just going to do half of it. So this blue graph is the graph of the secant function in this case.